In this video, we will talk about the product and the quotient rule. Up to this point, we've done the power rule, and we've dealt with sine of x and cosine of x and e to the x. So those are the things thus far that we could take the derivative of. Now, we've done something like this, and I told you to just rewrite the constant and then derive that to get cosine of x. Now that we could do product rule, I can show you why it works out to be this. And the product rule is going to be the first term, so it's the first times the derivative of the second plus the second times derivative of the first. Now, order doesn't matter for product rule because we are adding, but again, it's the first function, derivative of the second one, plus the second function, derivative of the first. Let me show you why this works out to be this. And you would never, ever, ever do product rule for this. Let me just show you why it does work. We would do, well, let me start back up here. So we would do the first times derivative of the second plus the second times derivative of the first. All of this goes to 0. We get 3 cosine of x, which is what we got. So that is why when you have a constant, you can just sort of take the constant out and then do the trig function. We also did it with e to the x, okay? We said if it was y equals 3e to the x, it's the same idea. We could do the first times the derivative of the second plus the second times the derivative of the first. That just goes to 0. Then we have the quotient rule. Quotient rule is going to be low d high, so it's low, derivative of the top d high, minus high d low over the bottom squared. And then additionally here we have all the trig functions. We've done sine and cosine, sine of x, cosine is negative sine of x. Now we've got tangent, which is secant squared. Secant is secant tan, cosecant is minus cosecant minus cosecant cotan, and cotangent is minus cosecant squared. One way that students do remember, all the cos are negative. Cosine is negative, cosecant is negative, and cotangent is. The first one, I'm going to do the product rule, so we're going to say dy dx. It's the first times derivative of the second plus the second times the derivative of the first. You do have to simplify, but you don't have to go crazy trying to simplify. If you look at the not the WebAssign, but even CalcChat sometimes goes super crazy with the simplification. So don't worry too much about it. Try to clean it up a little bit. If I distribute here, we're going to get 9x cubed minus 12x squared plus 3x cubed plus 15. We can say 12x cubed minus 12x squared and then plus 5. I have the first times derivative of the second plus the second times derivative of the first. I'm going to do this off to the side. This is x to the 1/2 power. So it becomes 1/2 x to the negative 1/2. So again, this is first derivative of the second plus the second derivative of the first. 1/2 x to the minus 1/2 power. F prime of x is going to be equal to root x cosine of x plus sine of x over 2 square root of x. This is a quotient rule. Now, sometimes you can take the denominator, rewrite it to the top as a negative exponent, but sometimes that's not always better. For right now, we can't even do that just because it requires the chain rule. But I would say just stick to the quotient rule. It's going to be low d high. Low d high minus high d low all over the bottom squared. I'm going to simplify the top a little bit. And again, you don't have to go crazy, but you do need to simplify a little bit. So ultimately we end up with 6t squared plus 30t plus 2 all over 2t plus 5 squared. We have low d high minus high d low all over the bottom squared. Not much you can do here. Minus t cubed sine of t minus 3t squared cosine of t over t to the 6th power. You could, I'm not going to require it, take out a t squared, and then take out a t squared out of that. But you could leave it. Find the slope of the curve at the given point. That's another way to say find the derivative. This is a product rule. First times derivative of the second plus the second times derivative of the first, which is just 1. I'm not even going to write it. We've got negative pi over 6 times sine of pi over 6 plus cosine of pi over 6. We're doing this at pi over 6. So again, we have the product rule. So it was the first derivative of the second plus the second derivative of the first, which was just a 1. Sine of pi over 6 is 1/2. Cosine of pi over 6 is root 3 over 2. We could leave it as negative pi over 12 plus root 3 over 2. Number 6, we have a quotient rule. It's low d high minus high d low over the bottom squared. And we're doing this at 0. You can simplify, but quite honestly, you're plugging in 0. You're going to notice here that a lot of this cancels out. I wouldn't even waste your time. They just want the slope at the given point. So they want the value. You don't need a simplified slope. When you plug in e to the 0, e to the 0 is equal to 1. All of these go away. Sine of 0 is 0. I have 0 minus the cosine of 0. Cosine of 0 is 1. 0 minus 1 is negative 1. Number 7, product rule. We have the first times derivative of the second plus the second times derivative of the first. I don't think there's much you can do here. If you wanted to, I suppose you could simplify, or distribute, I should say, negative x sine of x minus sine of x plus cosine x. All I did was distribute this to that, and then that to the 1. This is a quotient rule, f prime. We're going to get low d high minus high d low all over the bottom squared. X cubed squared is x to the 6th power. And again, not really much you can do here, f prime of x. Certainly on a multiple choice, they probably would have factored out an x squared. So if we were to do that, let me just do that just in case, make sure everybody understands. You can take an x squared out of this, so you get x cosine x minus 3 sine of x over, you get x squared times x to the 4th is x to the 6th. Those cancel, and that would be our final answer. For number 9, we've got g prime of x. It's the first times derivative of the second plus the second times derivative of the first, which is 1, and then that's by itself. So this was product rule here, and then I have cosine of x, which is negative sine of x. Cancel, cancel. G prime of x, we have x cosine x. For number 10, dy dx, I'm going to treat all of this as my first term. First times derivative of the second plus the second times derivative of the first. Negative 2e to the x sine of x plus 2e to the x cosine of x. Again, you can factor out a 2e to the x. The fact that it's not going to cancel with anything, there's really no point in doing that. And then for number 11, we've got a quotient rule, g prime of x. We have low d high minus high d low all over the bottom squared. And the second right is 2e to the x times x squared plus 1 minus 4x e to the x all over x squared plus 1 squared. Again, not much you can do here with simplification. You could take out an e to the x. You could take out a 2e to the x from both of these. But again, it's not going to cancel with anything here, so I don't really see that it's necessary. For number 12, 13, 14, they're asking us for the equation of the tangent line. Y plus 5 equals m, and then x minus 1. What I need to do is find the slope at 1. Y prime is going to be the first times derivative of the second plus the second times derivative of the first. You can simplify this, but since we're plugging in x equals 1, I would just go ahead and plug it in. I just need the value of the slope. And since 1 is such an easy number to plug in, I think it would make it much easier. If I plug in 1 here, I get negative 1, and I would get 2 here. So negative 2 plus, plug in 1 plus 4 is 5. I get 3. Take this out, put a 3 there, you're done. We have y plus 5 equals 3, and then x minus 1. Number 13, we have quotient rule. Low d high, low d high minus high d low all over the bottom squared. We're plugging in 4. I'm just going to drop it right into here. I want y f prime of 4. 4 minus 3 is 1. 1 times 1 is 1. Minus, plug in 4 here, you get 7. 4 minus 3 is 1. You get negative 6 over 1, which is negative 6. That's my slope. This is my m. You can say y minus 7 equals negative 6, and then x minus 4. And the last one, we've got a quotient rule. Low d high, low d high minus high d low, which is just 1, over the bottom squared. And again, I'm just going to plug in, because we're just plugging in 0. That goes away, that goes away. We get 1 on this end. e to the 0 is 1. 0 plus 4 is 4. On top I get 4 minus 1. Here we get 0, I get 16. I get 3 over 16. Let me double check that, but we got y minus 1/4 equals m, and then x minus 0. So we have low d high minus high d low over the bottom squared, plug in the 0. 4, so I actually get 4 minus 1, and then we plug in 0. 4 squared is 16, 3/16. Very good. Okay. Last one, it's asking us first, second, and third derivative. You can keep taking derivatives. Let's just go over the notation. You could do y prime, y double prime, y triple prime. You could do f prime, f double prime, f triple prime. You could do dy dx would be first derivative. D squared y over dx squared would be the second derivative. That's the notation for the second derivative. So on top it goes in between, on the bottom it goes on the outside. And then the third would be d cubed y over dx cubed. Just be aware of it. This is probably the most common notation, but they're giving us y, so I'll just stick to y. Y prime will be 20x to the 4th minus sine is cosine of x, and then plus 4e to the x. Y double prime, just keep going, 80x cubed. Cosine is negative sine, so plus sine of x plus 4e to the x. And then y triple prime would be 240 x squared plus cosine x plus 4e